So we are, I'm just giving you the notes for 6-2 day 1 that I would give you in class if we were meeting, and not a lot to it, but I'm going to walk through it. We're learning today on how to add fractions that have a common denominator to start. So one way to imagine how to add 2/5 and 1/5 together is to imagine that you had a pie or a pizza and you wanted to see what 2/5 look like. So if this is my this is my pizza, let's say, and we cut it into 5 slices, and you had 2 out of the 5, this is a visual representation of what 2/5 looks like. And the same pizza, same size, could be split into 5 pieces the same way. All those pieces have to be the same size. But you could imagine what 1/5 looks like, 1 out of those 5. So if you're adding 2 out of the 5 pieces to 1 out of the 5 pieces, that means that you would have 3 out of the 5 pieces. Again, same pizza, same size, all the pieces the same size. You would then have 3 out of the 5 pieces. The important part is they have to be the same size pieces, and that's what the denominator gives you. The size of the pieces from this pizza. Because it's fifths, they look like that. If they had been sixths, they would all be smaller. If they were halves, they would all be bigger. So unless you have the same size pieces, you can't put them together and say 2 of them and 1 of these is 3 if they're not the same size. And that's the reason why you need a common denominator. So the rule is you add the numerators, 1 plus 2, and you keep the denominator the same. It's 3 out of 5. That's how many pieces there were. So that's one way to present it. Another way to present it that I think is important is for students to see what's happening on a number line. So on a number line, if you make equal spaces between 0 and 1, each of these little dashes represents a fifth. So this is 1/5. Add on another fifth, that's 2/5. Add on another fifth, that's 3/5. And add on another fifth, that's 4/5. And if you add another fifth on, you're going to get 5/5. But that's the same thing as 1. So if you envision on a number line where these numbers are, then you can figure out where 2/5 is and start there. So this would be my starting point. And then you can add on a fifth, which is just hopping 1 over. That's how you add on a fifth. And you can end up at your answer. So you start at the first fraction, and then you add on by hopping. Again, fifths, all of these are the same distance. So if I start at 2/5 and I add on another fifth, I'm going to end up at 3/5 on the number line. The reason I like that is sometimes you have to do things like 2 and 3/5 minus 2/5, problems like that. And if you have a visual about here's 1, here's 2, 1, 2, 3, where you are in the number line, and you're going back, you can figure out easily where you end up, 2 and 1/5. So you can imagine, sort of hopping each of those fifths and where you end up. And so if I make you take 2 and 3/5 minus 4/5, which can sort of blow some people's minds because they're like, oh, wait a minute, if I have 2 and 3/5 and I'm trying to take away 4/5, I'm going to have to borrow. But not if you see it this way, because you can then go back another 2/5 and figure out exactly where you are, 1 and 4/5. That's what comes right before the number 2 if we're talking fifths. So if you understand how to subtract on a number line, then this whole idea of borrowing when you're trying to subtract fractions, I can't Some teachers say I can't take 4/5 and 3/5 without going negative. You're right. But you don't really have to. You can imagine it on the number line. We also have to talk about what do you do if they don't have the same denominator? Well, that's not a big deal. We talked about that last class. You can make them have the same denominator. You can multiply this denominator by that denominator, as long as you multiply the top also. You can multiply this denominator by that denominator, as long as you multiply the top also. So there's a rule for how to add fractions that have different denominators, and that is multiply their denominators together, multiply the numerator of this fraction by that denominator that the fraction didn't have, so a times d, plus multiply the numerator of this fraction by the denominator it didn't have, b times c. And so you are using this rule, but you have to remember then that you have to simplify. Sometimes, not all the time. If these don't have a common factor, then you're probably good, or you will be good. But I did an example where they did have a common factor. So this rule says multiply 150 times 10, that's your new denominator. I'm sorry, multiply 15 times 10, that's your new denominator, 150. Take 2 times 10 and add it to 3 times 15. So I end up with 20 plus 45 is 65. So here's my sum. But now I got to reduce it. Because they both have a common factor of 5, I got to divide 5 out of the numerator and 5 out of the denominator to get my final answer. But it'll always work. There's another rule. It's called the least common multiple. And if you use the least common multiple, you won't have to reduce or simplify. So the other way to think about this problem is, what's the least common multiple of 15 and 10? Well, it's 30, because 30 is the smallest number that 15 and 10 both divide into. So you rewrite each fraction with 30 as its denominator. So the first one, you take 15 times 2, and the numerator 2 times 2. Rewrite it. The second one, you take 10 times 3, so you take the numerator times 3. Now they have the same denominator, so you add the numerators and keep it over that denominator. So if you use least common multiple, you won't have to simplify. If you use the other rule, you might. And then the only other thing is subtracting fractions, and some people act like this is a whole new thing. It's not. It's if you write it as adding the opposite, you already know how to do it. Subtracting means adding the opposite. If I take 10 minus 6, it means 10 plus negative 6. So I really don't have to teach people how to subtract if they know how to add positive and negative numbers. And so the rules for subtracting with the same denominator are subtract your denominators and put it over your numerator. Backwards. Subtract your numerators and put it over your denominator. Or add the opposites. So a plus negative c and put it over b. So you can either subtract or add the opposite. And the same thing's true for non-common denominators. A times d minus b times c all over bd. Or if you want to write it as addition, write it as adding the opposite. So that's just a quick refresher on how to add and subtract fractions. I know that your calculators can do it. And I know that you can plug them into your calculator and do it. But you need to be able to explain to me how you do it on the quiz, so make sure you take the time to understand it yourself and not simply rely on your calculator. You can rely on your calculator to check your answer, but you cannot rely on your calculator for the test because of the way I'm going to test you. I'm going to make sure that you know these rules and you know how to apply them.